Welcome to our Flutter Embedded tutorial. In this series, we are working on a basic serial communications Flutter app using the Raspberry Pi. Our goal is a basic Flutter app using serial communications via the Raspberry Pi UART and another computer system. In this part of the series, we will code the UART Service Dart file. This file handles all of the serial data processing for the user interface. To get started, we'll create the src folder and the UART Dart file. Bring in the imports for the UART Service class. Stub out the UART Service class. Initialize the hardware UART and create a serial data variable. Code the stream controller for asynchronous data flow. Code the async method and polling loop. Code the stream to add received serial data from the UART. Code the try, catch, and exception block, and code the future delay duration. And finally, create the sendData method and the dispose UART service method. Let's get started creating our folder and Dart file. Hover over the lib folder and right-click. Select New Folder and name it src for source code. Right-click on the src folder, then select New File and name it UART_service.dart. Please pause the video if I am going too fast, and then restart when ready. Open the UART Service Dart file. Now, let's create a variable to hold our serial UART data. To manage our asynchronous data, we will code a stream controller. I'll create a comment and then create the variable to hold our serial data. Oh my, I forgot to tell you to create the serial variable, s. Please pause the video, copy the code, and the restart. We need a string variable, and let's call it datastring to make it easy to remember. I suggest you have auto-save turned on, and also occasionally hit Ctrl+S to save your work. When you save your file, the code is automatically reformatted. I've created another comment, and will cut and paste this code. If you need more time to copy the code, pause the video and restart. I have also included a link in the YouTube description to the GitHub repository where you can access the source code. Let's code our getter method that provides access to the stream of serial data. I am using Dart arrow notation to return the expression. If I am going too fast, please pause the video to copy my code. You can also access my GitHub repository and cut and paste the code. Now when the datastream getter is accessed, it returns the stream string which is managed by the datastream controller. Moving on, let's go over what we will code next. To code the startListening method, we will develop the code for our variables, create an infinite while loop with exception handling, stream received UART data, and code the while loop await future polling loop delay. Let's start coding. We'll get started by creating a comment. This is an async method indicating it will perform asynchronous operations. Since this method does not return anything, we use void. We use the keyword async to make the method work asynchronous. I'll code the data variable and initialize it with 256 and 0. The 256 is how many bytes we can read and 0 is a timeout value. Hover over the various parts of this code to get more information. To organize my code, I'll add some comments. Let's create our infinite while loop. The purpose of this infinite loop is to read data from the UART continuously. I'll add another comment. Let's code the try part of the try-catch block. This part of the block attempts to read up to 256 bytes from the UART interface. Converts the read data to a string and stores it in data string. Checks if data string is not empty, and if true, adds this data to the stream controller, which will notify all listeners of the new data. We need to convert the variable, data, into a string. Now let's check if the data string variable is empty or not. If it is not empty, add the data to the stream controller. This is the catch part of the try-catch block. If there is an exception in the try part of the block, the catch part of the block will add that exception to the variable, e. You can use the e variable for more advanced exception handling, but in this app, I will use a simple debug print to show the exception. To throttle data reading, we'll add a delay. The await keyword is used to wait for the future to complete before proceeding to the next line of code. Future delayed is a static method of the future class in Dart. It returns a future that completes after the specified duration. Duration specifies the duration for which the future will be delayed. Duration, milliseconds, 1000, creates a duration object representing 1000 milliseconds, or 1 second. You may need to adjust this for your custom applications. The use of async, future, and await are all Dart multi-thread operations to provide non-blocking to the main UI thread. I'll go ahead and add a comment here to tidy things up. Remember to save your work as you are coding. This saves and reformats your code. Now on to the final code for the UART service class. We will code the method to send data to the Raspberry Pi UART. Finally, we will code the dispose method. This method is called when we want to free up memory to avoid memory leaks. Let me add a few comments at the end of the curly braces so I don't get mixed up later. I'll start coding the method. Oh crap, I forgot to create the comment. There, that's better. Sorry for that. This method does not return anything, so we'll use void and call the method sendData. The method takes a string variable and we will call it data. S.write is an instance of the serial class, and the write method of the serial call sends the byte array to the UART. Data.codeUnits is a property that returns a list of the UTF-16 code units of the string. Essentially, it converts the string into a list of integers where each integer represents a character in the string. uint8 list. From list takes this list of integers and converts it into a uint8 list, which is a list specifically designed to hold 8-bit unsigned integers. This is necessary because the UART interface typically works with byte arrays for data transmission. Wrapping up, we'll code our dispose method. Let's first add a comment. The dispose method in our UART service class is used to clean up resources associated with the serial instance, S. It calls the dispose method of the serial class to ensure that the UART interface is properly closed and any allocated resources are released. This helps maintain the application's performance and stability by preventing resource leaks. Since this method does not return anything, we'll use void. S is an instance of the serial class, which handles the UART communication. The dispose method of the serial class is called to release any resources that the serial instance is holding. This typically includes closing the serial port and cleaning up any associated buffers or threads. Let's add one last comment and save the file. Congratulations on coding your UART service class. The UART service class encapsulates the functionality for UART communication, providing methods to send and receive data over a serial port and managing resource cleanup. It uses Dart's stream controller to facilitate real-time data handling and ensures that resources are properly disposed of when no longer needed. Thanks for watching. This wraps up this part of the tutorial. Stay tuned for our next installment where we code the user interface and test the app. Remember to smash the like button and subscribe for more great content.